Recall that the purpose of the evaporator is to absorb heat from the air. Absorbing heat from the air is what provides cooling in the refrigeration cycle. Evaporators contain a series of coils filled with refrigerant. These coils are the main part of the evaporator. Remember that refrigerants absorb heat by using the air's heat to boil, changing phase into a vapor. The evaporator coils increase the total surface area over which air can flow. This speeds up the heat removal process. Increasing surface area will always speed up the rate of both heating and cooling. To think about how surface area affects heat transfer, let's think about making a steak. When we cook a steak, we cook it flat side down. The part of the steak that is in contact with the pan is the surface area where heat transfers to the steak and cooks it. Now, let's think for a second about cooking a steak as is pictured here. Our gut tells us that this is wrong. We know that the steak would not cook evenly. In this example, the surface area where heat can transfer from the pan to the steak is much smaller. So it would take much longer to cook the whole steak, and the steak would cook unevenly. We see with this example that the larger the surface area, the faster heating can happen. The same is true for cooling. In the evaporator coils, the refrigerant starts as a liquid. It absorbs heat from indoor air to change state to a vapor. In this picture, we see the solid blue color, which is the liquid state of the refrigerant. The bubbles indicate the vapor state the refrigerant turns to. So in the evaporator, we have refrigerant in both liquid phase and vapor phase. It is important to remember what state the refrigerant is in for each component of the refrigeration cycle. The specific requirements for an evaporator depend on the type of system we are looking at. There are three main categories of systems: refrigeration systems, air conditioning, and chillers. We will take a look at the types of evaporators used for each type of system.